Class, we are close to the end of, so this is one of our last new topics, and let's jump in and see what we are going to cover today. First is we are going to look in the searching and sorting this week. Why we are looking for searching and sorting? Example, for searching, we in the real live we can figure out about the phone book or dictionary or playlist or files. The simplest way, when we have a large amount of data, we want to search the data for a particular value. For example, we might to search a phone book for a person's phone number, or we want to sort a list of students grade based on their student ID or a student name in the real life. We have different searching approaches: sequential search, binary search, and searching object. And for sorting, we have to cover two kind of sort: selection sort and merge sort. First, we are going to look into a sequential search. Sequential search check each element in the array one by one. That's a very simple way to search an array because we all have one loop over the elements at the array, and also that's not efficient because the runtime is O n. The next slide, we have a sequential search code example. In this code, we are searching a target. We have one for loop indexing 0 to length of the array and increments of one by one. And in the sequential search, if we find a target, we return the index. If we cannot find the target, return a negative one. And the complete of the code in the sequential search algorithm is linear ON because it contains one loop that traverses at most n elements because you have indexes started with 0 and length of the array. But this way is not efficient. We are going to next search, that's a binary search. Binary search, the runtime is O log n. We are looking for half, and we work on the sorted data or sorted array. Here we have some array, and we are looking for example 42. The index returning, if we find the target, is indexed by 4. Here is a more detail about the binary search. If we are searching the array, for example here for 77, The index of the 77 is 10. We have to sort array. We have 3 indexes, min, middle, and max. That's very important. Index 0 is minimum. Maximum in this specific example is 14. And the middle of the indexes is 7, because middle between index 14 and 0 is 7. So for binary search, we have 3 indexes: minimum, middle, and max. If the number of middle is too small, we have to move to right. This can help us to eliminate half of the array and speed up the searching. Here we are going to right side of the array and eliminate the left side of the array. The next step, min going to index 8, max is 14, and middle between 8 and 14 is 11. Because number middle is too large, 82 is too large, we are eliminate the right side of the upper side of the array. We are looking for the left side. The next step, change the minimum, middle, and max again. Here minimum is index 8, middle is 9, and max is index 10. We have number middle is too small, because 72 is smaller than 77. We are move to right. When we are moving to right, we find the target. Target is 77, and minimum, mid, and max shows in the last line the same indexes, and we find the target. This way is very efficient because the runtime is O log n, and we eliminate half of the array. So binary search is more efficient than sequential search, because in the sequential search, you are looking for one by one. That's the simplest way, but the search is not efficient. Here, that's the implementation binary search algorithm, and we have min, max, we find the middle. Again, if the middle depend on the middle, if the middle is too small, we are move to right. If the middle is too large, we move to left. This strategy helps us to eliminate half of the array and speed up the search time. This sequential search algorithm in Java, we have other options you can use. If object index I dot equals, that's a method you can use in the Java. That's a simple way if you want it. In summary, in the sequential and uh, binary search. Sequential search, we have runtime O(n), and binary search, we have O log n.